Hello, folks, and welcome to Iron Beetle, a show where we, upgrade distributed databases. More seriously, this is the place where we do learning. We learn how we can build a modern, even actually cutting-edge database using your own hands. And when we learn how to build database, the way we do this is not by, taking some building blocks and combining them together into big new shining database, but actually by going and writing every single block with our hands. So for the past 3 episodes, I think at this point, about 3, we've been looking at the upgrade procedure. So how we take our database and move it from version 1 to version 2. Normally, the way you do this is by ensuring backwards compatibility. You just make sure that from the perspective of the client, database version 1 and database version 2 behave identically, and then you could, Indiana Jones, swap them out and no one will notice. This approach doesn't work for TigerBeetle. Because besides the public contract about the database interface that TigerBeetle must adhere to, there is also internal contract. And part of the internal contract is that all the replicas should have the same data file, not just logically the same, containing the same mapping, but physically the same. So if we contain the same tree in this shape on one node and in that shape on another node, it's game over. TigerBeetle doesn't work. And the reason for that is that TigerBeetle assumes that a disk can fail. I realized that I forgot to share my screen, but you didn't miss anything. So basically, this is the logical data that the database stores some mapping from letters to numbers. And physically, this mapping can be represented as 2 different shapes of a tree, where A, B are on the left, or where B is in the root. And although logically these 2 trees store the same data, physically they be represented differently on disk. And that's going to be a major hurdle for TigerBeetle, because TigerBeetle assumes that the disk can fail. That you wrote some data to disk yesterday, today you are reading it again, the same data on the same offset, and you get some garbage. Checksum doesn't match. because there is some hardware corruption, or maybe there is buggy firmware, or like whatever. Like for whatever reason, disk wasn't actually able to correctly persist your data. And for Tagabidal, this is not a problem, because Tagabidal is a cluster of 6 replicas. So if there is a local failure on a disk of 1 replica, it could always go to another replica and ask, hey, please, could you give me this slice of your hard drive? I want to repair mine. But that only works if the data physically is the same. So if we are running upgrade procedure, and it so happens that 2 of the replicas end up on different versions, and they end up creating logically identical but physically distinct data structures on disk, this breaks this repair. So we want to ensure that the disks are physically the same. The way we do this is by enforcing an invariant that every operation in Tagabidal's log of operations is processed by exactly 1 version. And that means that we need to have certain handoff procedure. We need to say, okay, so op number 20 is the old version and op number 21 is the new version. And to make this handoff as seamless as possible, what we do is that we actually pack several versions of Tagabidal into the same physical binary, so that the binary we ship to you could actually run several versions of Tagabidal. And so during upgrade, there is the logic which dynamically switches from one version to the next version on the correct op. So that is the general story about the upgrades. Last time, we looked at, oh, sorry, let me flip this to dark mode. Last time we read and actually went and refactored the build multiversion logic, which makes this fed binary by combining several versions into a single binary. And the way this works is that we stuff this is it. We stuff extra data as sections inside the L file. I think we covered most of those things. The only thing we didn't cover is how we do the same thing for macOS universal binaries, but that's essentially the same idea. So you have, for macOS, you want to produce a binary which can execute any version of Tagabidal and can execute either on ARM or on x86. And well, the way we do this is the same. Both versions and architectures are stuffed into different Mac. Oh, here. So it's I don't want to cover this because this is not particularly illuminated. And yeah, everything else I think we covered. Okay, so and now we have 2 things to discuss left. One is how we physically do this dynamic execution of the newer version. Like, if we are running an older version and realize that, hey, we are doing an upgrade, so we now should jump into the new version, how we physically do this. And the second is, how do we figure out which operation should we switch to a newer version of? And I guess today we are going to start to the second part. So the goal of today is understand how we logically decide that the time has come to upgrade. Okay, so let's first go to main, because here I want to show you parts of the interface. So this is part of the interface which is exposed to our logical VSR state machine, to our replica.zig. And this function, replica release execute, does what it says on the tin. So it takes a particular version number of TigerBeetle and re-executes the binary itself with that version. And that assumes that this version is there. So if that version is there, we like somehow do like this re-execution thing, which we'll cover probably in a week. And if there isn't one, like, we say, hey, release not available, and we panic. So the goal of the logical upgrade protocol is essentially to figure out what is the right way to, like, when we should be calling this version, when it is appropriate to upgrade. Okay, so let's go to the, okay, I think I should show you what is a release, but it really is just like, three numbers, like patch, minor, major, encoded into a single U32. So nothing particularly interesting. So okay, I think yeah. Interesting thing is this thing. So in Replica, we have release bundled. And that is like a little bit of a hacky API, but this is a pointer to release list. And release list is multi-version release list, which is like certain number of releases. So what is the semantics of this thing? It is a set of releases that a particular replica can have. And the twist is here. So, okay, imagine we have a cluster and the replica is running, like, running for a day, running for 2, running for an entire week on the latest release. Well, after a week, we release a new version of TigerBeetle. So now, once we have this new version, we should somehow upgrade our old binary. The way this works is that we, not we, developers of TigerBeetle, but the operator just copy-pastes the new binary over the old one. So it's like physically CP's binary on disks. And the running TigerBeetle process actually looks at the binary which lies there on the disk and notices that the binary has changed, reads the binary, figures out what new releases are there, and communicates this list of new releases to this release bundle struct. So bottom line here is that this release bundled upgrades at runtime when the operator actually does the physical upgrade. And the logic which we will execute, I think, is that we will wait until almost all replicas in the cluster have a new release available. Once that happens, primary decides to do a release. Primary decides that like a particular operation and actually a particular future operation will be like the operation where we switch to the new release. Primary pumps that operation through the VSR, so everyone agrees that, hey, we are switching to a new release at like op90, and then replicas, and again, that op90 is in the future, then that replicas commit until op90, and when op90 comes, replicas re-execute into the new binary. Now, the thing is, when you re-execute the binary, you essentially crash and restart. And if you remember, the way startup works is that we have our data file. What is this? Why is there? Okay, never mind. So let's say that it is like this. So we have like this data file, and in this data file we have like a checkpoint. Checkpoint. And then checkpoint, I think I spelled it correctly. And then on top of this checkpoint, we also have a certain number of prepares in the log. So this whole thing is the log. Okay, so the process is that when you function normally, you append to the log and you apply changes to the in-memory table. So above this all, there is also like memory. And the memory remains. So you go, you start from checkpoint, you apply, you accept, and you prepare, you append it to your log, and you like execute this prepare. You do the transactions and you apply changes to your in-memory data structure. Once you get to the next checkpoint, you will flash memory changes to your disk. But if you crash and restart in the middle, for example, if you're doing an upgrade, what happens is that the memory does not remain. The memory goes away and you need to start reprocessing the same data from the checkpoint. And this creates a problem because, like, if we say that, hey, like this op in the middle of a log is an upgrade, upgrade, you're sort of in a bind because, okay, you start with an old version, you do this op, you do this op, you do this op, and okay, you learn that, okay, this op actually should be done by a new version. So, okay, you say, okay, never mind, I do have actually a new version on my local disk. So I execute in the new version, but that means you need to start from the beginning from a checkpoint. And you are on the new version and you go to this checkpoint and you want to execute the new version, the next op from a log, but that op requires older version, and you're like, oh dear, like doesn't work. Okay, I need older version. So you execute the old version. Okay, on the old version, you do this, you do this, you do this. You think, oh, okay, stop. I need a new version. You're executing the new version, and like this repeats. Like you can't really process upgrade if it is in the middle of the log. So that is another important thing we want to, another invariant for us to ensure. We want to make sure that upgrade happens exactly at the checkpoint boundary. So you essentially want the upgrade operation itself be a no op, an operation which doesn't have any behavior, and for that reason behaves identically on the old version and all the new version of TigerBit. So that means that the job of the primary once it decides that it is time to update, is to pad the log until the next checkpoint with like fake dummy operations, just so that everyone gets to a checkpoint. And then everyone checkpoints, and after they have checkpointed, the checkpoint is stamped with the new version, and we can restart from it. So actually, let's look at this. In the Superblog, I think Superblog. Yeah, in the Superblog, we have checkpoint state. And what is checkpoint state old? I wonder if we should actually remove this. Okay, let's file pull request here. Well, not a pull request, but see if we can. I want to lane this. Okay. Let's see. I think we changed format of the Superblog at some point, and perhaps we can remove it. Remove now. Okay. So ignoring checkpoint state old, like the new shiny one, and the new shiny one checkpoint state, we have this release which says, hey, like from this point on, you are supposed to use this particular release version. And correspondingly, in replica, okay, I forgot the shortcut. Happens all the time. Yeah, in replica, I think, let's see. So, like, when we start, we don't actually know which version we are supposed to be running at. So we create Superblog, then we open the Superblog, and does it happen in the Superblog open context? No. Wait. Where does... There should be... Should be code somewhere which checks for... Okay. So I'm trying to find the code where we actually call release execute. So release transition. Okay. Release where we do release transition. Okay, yeah, this actually happens slightly later, and I don't kind of like get it. Well, I guess this is for like WOP related reasons, because, well, you see that's kind of like that's a tricky thing. The production function release execute is now return, because we like literally like replace the old binary with the new binary. But in the simulator, obviously, like you cannot have no return function. Like there is no stack and widen in Zeek. Like you need to do something. So actually, in the simulator, this is a return function, and after it returns, we well, actually, that means that we need to take a look at how we simulate release as well. That's added to our stack. Well, let's do edit to our stack. Upgrades plus Whopper. Okay. So the way this works is that in Whopper, during upgrades, we essentially just return from the replica, and then Whopper says, okay, so actually we should trigger upgrade for this particular replica, and then Whopper simulates upgrade logic. Okay, so anyway, in the open, after we opened our superblog, we see what release we should be, and then compare it with our own release. And if they are mismatched, then we do and restart into the requested release. Okay, let's actually see this release transition function, because I think now we should understand everything, because it's not that simple. If we are downgrading, that means that we started with an old data file on disk. So we upgraded the replica, we restarted the replica, but the cluster haven't actually went through the upgrade process. So it is still should be running on the old logical replica. And that's like, maybe we are asserting that, hey, we are at the checkpoint and we just opened the journal. If we upgrade in, then yeah, we should be checking that we are at checkpoint. I actually don't understand why we could be. Oh, right. Okay. So remember that there is a certain amount of lag to the checkpoints. So if these are the ops, and this op here, I missed it. Okay, if this op here is the checkpoint, we decide that, hey, we want to write this option, we want to write this op to disk. But because writing an op to disk takes time, we only write it to disk once we get to that point. So there is like this certain amount of gap while we are writing the checkpoint. And if you are a replica, the primary, which decides to upgrade, you transition at this point. You say, hey, I need to transition to a new version because I've just written fully the checkpoint, which says, hey, from this point on, we need a new version. And that actually means that all these ops must be no ops as well. So anyway, we see release transition here. On the other hand, if the replica says, hey, I want to release transition, but then it crashes and restarts, then it might see that, hey, I'm at this point because we start from a checkpoint, but actually it is time for me to transition. That's why we have two possibilities here. And we might or might not open the journal. Okay, so then we do release execute, and release execute is a callback, which we set to in main to this like physical release execute, which is no return. And this is the tricky part. The physical release execute is no return. The actual is void because the Whopper 1 will be void as well. And well, like no return functions are a subtype of void return functions. So this checks out. Okay, so I guess this kind of like gives us the idea of the overall upgrade flow. And now we need to see, so kind of like we know how we upgrade once we decided to upgrade, once we picked a specific checkpoint for upgrading. Now we need to figure out how we do decide that. And there are two components to that. One is learning that every other replica in the cluster has the new release, and the other is sending those no-op iterations until we part to the next checkpoint. Okay, and I have no idea where that happens. So let's see. Okay, so we have like upgrade release. The release we are currently upgrade towards. Let's work backwards. Let's see where that is set. Okay, so here we process release. Okay, so apparently we upgrade that. Oh, okay, so request isn't actually request, as in like the side request. It's like the payload for upgrade request. And actually, okay, let's see, what is an upgrade request? It is just a release. Okay, nothing fancy here. Okay, so presumably then the way we decide to upgrade is that the primary sends a request to upgrade to itself, so that when it executes this request, and at the point of executing request, it kind of like, oh, gee, I should be upgraded. Okay, so let's see. Where we do this finally, primary. Okay, yeah, okay, yeah, I've got it. Send request upgrade to itself. So this is done by the primary in the normal state. When we decided to upgrade to a newer version. Okay, let's see. To request upgrade to self. Okay, on upgrade timeout. Okay, already upgrading. Well, already upgrading flow, I guess we'll look at afterwards. Let's see the initial flow. Okay, so presumably there is upgrade timeout, which periodically ticks. And we say, okay, if this is upgrade timeout, we go and we look at the list of our bundled releases. And we find we look only at the releases which are after our current release. And we count all the replicas which have this release. And okay, the latest release for which we have upgrade quorum, we decide to upgrade to it. Okay, and then we say, okay, let's upgrade to that thing. Okay, that makes sense. What are upgrade targets? So for every replica, we see what releases that replica has and checkpoint and view. I don't understand why we need checkpoint and view. Well, we'll see. Well, let's see how we do this. Okay, constructed from pings. So we know that this is going to be from pings and pongs. Let's see. We sent ping in on ping timeout. Okay, so working backwards, we realized that, okay, kind of like this all starts with a ping. This initial iteration, which actually is not that trivial. Where do we do releases? Okay. Verify release list. We check that whatever bundled releases we have is reasonable. So they are sorted list graphically, and we actually have a release we are currently running. That makes sense. Which actually means that if you replace TigerBeetle with a version on disk, with a version which is sufficiently far in the future such that it doesn't intersect with the old release, well, it'll panic. Well, fine. Okay. So then we go and memset. Oh, okay. No. We memset the pattern, like the trailer for 0, but there we actually just go and copy all our releases. Okay. Then on Pong, we should use this information to learn about releases that other replicas have. Well, not on Pong, on Ping. Okay. We fetch upgrade target for that replica. And okay, now I see why we need checkpoint and view. We basically want to figure out which upgrade target is earlier and which later. So if we don't have an upgrade target, or if we advance the checkpoint, or if we advance the view, we go and say, okay, now we have this new upgrade target. And then we verify release list and add them to upgrade targets. Now, again, now on upgrade timeout, we actually go and see, which replicas have release, and if there is a and if there is a release which we should be upgrading to, so a release which is higher than our current release, and a release which is upgrade quorum. And what is our upgrade quorum? Quorum upgrade. Okay, like quorum upgrade is like every single replica. So actually, if there is one replica in the cluster which is not upgradable, we kind of like say, okay, we don't do upgrades. Okay, that makes sense. Okay, we do send request to self, which sends message to ourselves, and as per that comment, we should be rejecting duplicate upgrade requests. Do we actually reject duplicate upgrade requests? Because, okay, I'm starting to slightly worry here on upgrade timeout. So here we say, yeah, if there is already an upgrade request in our pipeline, ignore request message duplicate, we'll ignore this one. So we actually don't care that, like, at one point we say, hey, let's upgrade to version 2, but the very next point we say, hey, let's upgrade to version 3. So presumably only one request will be carried out. But do we actually have this logic? Upgrade. We don't seem to have it here, which is concerning. Okay, let's see. Ignore. Request. Okay, yeah, there's separate ignore request upgrade. So on upgrade timeout, ignore request message upgrades. We'll ignore this one because it's the job of this particular message. Let's see what happens here. Okay, if this is an upgrade request, we don't try to upgrade to the current version. We don't try to upgrade to an old version. And if we are currently upgrading, then we are duplicated. But where do we set upgrade release? Okay, this doesn't make sense. Upgrade release. Where are we setting it to something? Like we set it during execution, right? So does this mean that we actually can queue 2 upgrades? Okay, this is curious. Okay. So otherwise, okay, actually, oh dear, I'm read it again. I'm not good at this. But actually, this is a good time for a raid because we discussed how like Tigerbeetle does upgrades, and like it is crazy because the way we do upgrades in Tigerbeetle is that we literally concatenate several versions of Tigerbeetle into the same giant binary, and that is like giant binary automatically re-executes itself when it figures out that it's time for upgrade. I wonder if like Zig should do the same. Like when Andrew executes, then Andrew upgrades the compiler, makes a new release. What he could do is that he could bundle like the old version of Zig and the new version of Zig, and then if you type Zig build, the thing looks at the Zig version in the build .zig.zone, and if it's the old version, we re-execute our compiler bundle with 2 versions into the old compiler version in the upgrade mode. So that thing, which still has like the old semantics of Zig, whatever, like the old parser, it compiles all the code in the upgrade mode, meaning that just goes and applies upgrades inline because it knows the old semantics. and then it like updates version of Zig and builds Zig's own and re-executes in the new compiler. Well, that's bad idea for Zig, definitely, but actually good idea for TigerBeetle, because that's what we are doing. So anyway, before we do this dance with re-execution, we need to figure out that, hey, it is time to re-execute, because we need to decide for the entire cluster when exactly are we going to do this flip from the old version to new version. And we do this by sending our upgrade request. And what I'm struggling to see here is that I think we should be protected from sending two upgrade requests at the same time. And I'm not seeing where it happens. Well, actually no. Okay, I think I see it. Let's see. Ignore request duplicate. I think it is there. So, well, no, it is false. We aren't ignoring a duplicate request if it is an upgrade. Okay, this is deeply concerning. Okay, well, let's see there, because it feels like it is a bug. So okay, if we don't ignore the release, then we do pipeline request. Well, I'm not sure if there is any special handling for upgrades. So let's just see. So upgrade timeout we have seen. On upgrade timeout we have seen. Execute. We have seen. So this is where we do this. Execute of upgrade, ignore request, upgrade, duplicate. Okay, this is, this is strange. Primary pipeline prepare. Okay, maybe we do this here. So if we are pipeline and prepare is an upgrade. Yeah, if we execute an upgrade and we are before checkpoint trigger, we we actually are upgrading to the same thing. So that is going back to our picture. This is the difference. So on the initial execution, these operations over here, they are executed by the old version. And then we get to the point where a checkpoint is fully durable, so we restart. And after restart, these operations here will be executed by the new version. So when I was telling you that there is an invariant in TigerBeetle that each operation is executed by exactly one version of TigerBeetle, that was actually a lie. Because the upgrade operations themselves could be executed by either the old version or the new version. But then this is fine because the upgrade operations actually are no ops. So it is very easy to do nothing the same way in the old version and in the new version. Still, I do think that we have a bug if actually, okay, let's see if it is code by versions. Okay, this is the bug. Allegedly, maybe not. Maybe I misunderstood. So on release on upgrade timeout. So basically on upgrade timeout fires 2 times, and we send different versions to ourselves. We don't ignore a request here. Because like there isn't like there is a code to ignore requests if the upgrade release is already set, but the upgrade release is only set once we get to executing that operation. So let's see what happens there. So we actually go and we will well, okay, I don't see so upgrade, but after upgrade, it might be the case that so we receive upgrade, but then we receive a bunch of other requests, and we don't know that we're upgrading yet. So we also add like normal. Okay, so I'm probably missing this. Okay, we do. Okay, I'm not seeing this. Okay, maybe I misunderstood how this field is set. So yeah, if we are upgrading, but we are not upgrading. So commit execute. Commit execute is the overall execution pipeline. So the op execute is kind of like the actual execution, and then this is the decorator. So after we did op execute, if we are upgrading, then we send request upgrade to self. So until we actually, I guess, reach the checkpoint where we need to say, okay, now we are upgraded. Okay, but still, so in the execute op, what we do with upgrade release? Okay. Yeah, so this is I think the invariant which will at least make us crash if we incorrectly do not ignore duplicate requests. But I think we should be doing this. So upgrade. Okay, so what is execute op upgrade? So we check this. Okay, so this is how does it happen? Upgrade release else. So we assert, okay, we assert that prepare queue only has one prepare, and that request queue has empty. But why do we? Okay, I don't get it. Like how? Like where do we do this? Okay. Okay. Maybe this is it. Oh, okay, yeah. Okay, so if the request is not upgrade itself, we do ignore this here. So we say, okay, if we have an upgrade pipeline, then we are going to skip any further requests. That is nice. But if we do get here, I think this is a bug. Okay, yeah, that's fine. Again, this shouldn't really be happening, because like upgrade timeout is like some timeout, and probably by the time the timeout fires, we actually execute the upgrade and ignore it because we are also already upgrading. But I think there is like, a window of opportunity where like replica might crash, and I mean, that's not a problem because it will restart, and then next time it will be all right. But still, it feels like it is a bug here. Okay, so I think okay, let's put it there. I will report next time whether we did find a bug or not. Oh, by the way, if you remember, last time we would do refactor. Well, now that refactor is merged. So thank you for helping. Okay, I think the only thing we're missing is when we do release transition, actually for upgrades, and that is commit dispatch. So after we commit it and we checkpointed the upgrade, then we do release transition, and there is one more here. Oh yeah, and after state sync. So that I guess that I guess it. So let's now that we've learned the thing, repeat it from the start. Replicas maintain a list of releases they have available, and that list is updated dynamically when the operator actually upgrades the binary on disk. This release list is broadcast through the ping messages, and in particular, primary maintains a mapping which says for each replica which releases it has. Periodically, primary checks whether the entire cluster has a newer release. And if that is the case, the primary goes and starts the upgrade procedure. The upgrade procedure is basically sending the request upgrade with a specific release to the primary, and then obviously to everyone else, and repeating this same upgrade request until the primary and everyone else is safely parked at the checkpoint. Once we did checkpoint with a new release, then we can safely execute in this new release. Actually, okay, I realized that I forgot to show one small thing, and that is exactly where we are checkpointing. Let me find this quickly. I think it will be equals self upgrade release. Okay, checkpoint. Do we have? Okay, can it? Well, we should have checkpoint data function. Okay, it's commit checkpoint data, not commit checkpoint. Okay, so here somewhere we should be. I think it is super block checkpoint. Okay, yeah, super block checkpoint. Yeah, and we ask release next for checkpoint, and release next for checkpoint is actually it is slightly trickier than I thought. Why it is not just upgrade release? Because Okay, yeah, because when we are replaying from the start, there are upgrade operations in the log, but we might not have yet set our upgrade release. Okay, that makes sense. So basically, once we get to the checkpoint, safely padded to with upgrade operations, we checkpoint and we stamp a new version in the checkpoint, and then we release transition, which means that we re-execute a new binary. And this allows us to maintain the invariant that every operation in TigerBeetle is executed by exactly the same binary, which guarantees that the data file is byte for byte identical. There is only exception, and that is the upgrade operations themselves after the checkpoint and before checkpoint trigger can be executed by either the new version or the old version, but because these operations are no ops, this also guarantees that the data file is the same. Okay, that's, I think, it. It was, I don't know how for you, but for me it felt really productive because I think we did find a bug. And if you want to know whether or not that is true, well, then please join me next week at 5 p.m. UTC, here live on Twitch, or, well, for those who watch it on YouTube, here on YouTube. Goodbye.